First, what is MLDA? MLDA is a new platform which empowers EEE or IEM students to pursue the application of machine learning, data analytics, and artificial intelligence, while at the same time provides students with an avenue to learn, research, and apply MLDA skills and knowledge to both the academia and industry. So it's one of the EEE clubs that focuses on machine learning and data analytics. And currently, we are also recruiting. So to know more about our portfolios, let's watch a short video on MLDA.
Learning and Data Analytics Lab here at the School of Electrical and Electronics Engineering at Nanyang Technological University of Singapore. My name is Jeffery. I'm the current president of MLDA at EEE. Here at MLDA at EEE, our vision is to empower our IEM and EEE students to pursue the understanding, application, and deployment of machine learning and data analytics. At MLDA at EEE, our student community consists of 4 major portfolios ranging from academic and training, career and external, logistics, and publicity. As a club itself, we also offer students a wide range of activities ranging from our machine learning workshops, career sharing sessions, to even machine learning datathons. All with one goal in mind, and that is to provide our students an avenue to learn, research, and apply machine learning and data analytics skills and knowledge to both the industries and academia.
Hi there, I am Liang Yu from Academic and Training Portfolio. We are in charge of teaching material, preparation, and presentation. Aiming to equip our students and alumni with analytical skills, we explore hands-on experience with them and produce lecture videos for the beginners in need. In Academic and Training Portfolio, student committees are more equipped with data science skills and also the communication and presentation of technological content. Teamwork also matters. We try our best to collaborate within and beyond the portfolio to deliver our creativities with their best quality.
Hi, I'm Wilson, and I'm part of the Careers and External Relations team. So we liaise with industry partners for collaborations in the field of machine learning and data analytics. Students will get a chance to have hands-on experience and project management in different projects. These projects will provide students with the relevant skill sets for their future career. Students will also get a chance to participate in talks and workshops by our industry partners. These will provide them with informed decisions about their future career path.
Hi, I am Andrew from MLDA Academics and Training team. Our objective is to educate and raise awareness on the field of machine learning and data analytics, especially for EEE and IEM students. We curate workshops specifically designed for EEE and IEM students, and we execute those workshops that not only increase the competency on the field of machine learning and data analytics, but also increase the awareness of machine learning and data analytics for EEE and IEM students.
Publicity portfolio at MLDA is responsible for spreading awareness about the club, what we do, our upcoming events, and projects that our members are working on. We're responsible for handling the social media accounts of the club and also designing posters that we put up around the school. It's our responsibility to generate interest among our peers here at the School of Electrical and Electronic Engineering. By being a part of this portfolio, the skills you can gain include design, scientific communication, and social media marketing.
Hey everyone, I'm Khai, and as part of the logistics team, we do 2 main things. The first being event planning. We think of how we want the event to flow, and then we plan accordingly. And the second being procuring the newest and the coolest technologies so that our projects team can work on the newest and the coolest technologies.
Okay guys, so as you have seen in the video, MLDA has a lot of opportunities for students who are interested in machine learning and data analytics field, or who is keen to know more about machine learning and data analytics. And currently we are recruiting for year 2 and year 4 students. And for those who are interested in joining us, can click the link that I will send after this. Okay, so before we start, let me talk about the Q&A mechanism first. So later, after the speaker finished their speech, participants can have 2 options to ask. So the first one is you can directly unmute yourself and ask the questions directly, or the second option is to use Slido. So there is an online platform whereby you can post your question there, and you can also upvote your other people's questions, and more importantly, you can ask the question anonymously. Yeah. Okay, so now let's go on to the first speaker, which is Jeffery. So he is a EEE year 4 student, and he has recently done his internship in the field of data science. So today he'll be sharing more about his internship experience. Okay. Okay, I'll send you the link for the MLDA recruitment and the Q&A session in the chat. Please check the chat. Okay, let's welcome Jeffery. Okay, Jeffery. Jeffery?
Yeah. So sorry. Could you come again? So I went for.
Okay. Okay.
Yeah.
Yeah. So yeah, please welcome Jeffery. You can start your sharing now.
Okay. All right. Do you guys see this?
Yes, I can see.
Okay. Cool. Yep. So thanks, Andrew, for the introduction. Today I'm going to share about how you should go about preparing for a data science internship. Okay. So firstly, who am I? My name is Jeffery. I'm a 4th year EEE student, and like many of you guys in the audience here, I'm also very interested in machine learning and data science. Right. So this, some pictures of me. It started back in when I was in 2nd year, when everyone was talking about like AI, machine learning, and whatnot. So I was curious, and I wondered if I could try machine learning as a career, right? So I back in the first few months of this year, I managed to secure an internship through the Overseas Entrepreneurship Program with a startup company in Israel called Safemode. So what Safemode is about is that it's a fleet management software company that aims to influence driving behavior for the better, to encourage safer driving so that companies can save costs on insurance, fees, medical claims, and whatnot. So the story of how the company started is actually pretty interesting. Yeah. So my CEO was actually in the army as a captain. Then one day his friend actually shared with him that his mom got knocked by a truck. So this inspired him to really set up a company to influence better driving behaviors, which not only makes economic sense in terms of insurance claims, and it also makes moral sense for the safety of the roads. So he co-founded the company with a professor in a uni there, which became also the chief scientist of the company. So my job, I was the only intern in the R&D department working with the chief scientist. So So he'll be the one giving directions, and I was the one executing on his directions. So my job was to figure out a way to predict a driver's number of safety events for every trip that he drives. So safety events here means sharp brakes, sharp turns, sharp accelerations, and whatnot. So using the data set, I was to predict the driver's behavior, and this will ultimately the mission was to develop a universal predictor that can predict driver's behavior in general, right? So using after this, although my internship was cut short due to the COVID-19 situation, however, like it really gave me many insights, and like after this internship, I wanted to use these insights to maybe like share about how bring some insights about how I would go about preparing for a data science internship. Let's say if I were to start from scratch over again, right? So some pictures of my company in Israel. So yeah, we were at a incubator where like there were many startups. So it was a pretty interesting experience. There were many PhD students many PhD graduates who became CEOs. They didn't really care about like postdocs or like any company at Google or whatnot. They all really loved entrepreneurship. So it was a good experience on my side, right? So now let's talk about how I would go about to learn data science and machine learning, right? So just to give some background, I first started to learn machine learning when I was in my second year, right? Second year, Sem 1 to be exact. So like I started off with basically like what you guys have right now. Like I knew basic Python. I took a Python course. I also knew some C from my intro course when I was in my first year. But other than that, I really knew nothing about machine learning. Right. So that was my starting point. Then in the winter break after my first semester, I really tried to discover like what it takes to secure a data science internship, right? Because that was my objective back then. So I realized that like when I did some research, I realized that there were really a lot of topics, like tons of topics that I need to master. So things like I need to know what a linear regression is about, what logistic regression is about, SVMs, random forest, neural networks. I need to know like programming packages like pandas, matplotlib, numpy, tensorflow. The list goes on and on. So like I was pretty overwhelmed by this, and I didn't know where to exactly start. So like that really like hampered my progress, right? So the other thing that was so after like I realized that I still went on to like my first approach was I went onto YouTube, and I really just went through some tutorials on machine learning, some code alongs. So like I did some projects about like stock price prediction of stock prices, using many different various models like regression, SVMs, blah blah blah. So I did many of these projects, but even though they were very interesting and definitely very cool, but however, I realized that it was difficult for me to actually retain the knowledge and the skills and the code after I finished them. So like after a few weeks, let's say I did a project on neural networks, keras, right? So after a few weeks, I would actually like kind of forget like how to do things, and I have to refer back to the code that I used when I had to tackle a similar project. So this was some of the issues that I faced when I first started out. Yeah. So how should you go about doing this, right? So after my internship especially, I got some insights, like, and I actually like went to prioritize what is important for someone to succeed in an internship. So I think first of all, the number one important thing that you should if all else fails, you should at least know how to perform practical, like how to use packages and perform practical data skills. So like manipulation, cleaning, visualization, and stuff. So these are, of course, like during my internship, almost 80% of what I did was really finding external sources of data, merging them into the data set, the data frame, data manipulation, cleaning, and visualization. So that was really 80% of the thing. So if you are good at this, you are really settled, like more than halfway. You're more than halfway there. So that is the number one, top priority. Number two, you need to be good at the theoretical concepts. So, but when I say theoretical concepts, I don't really mean the equations behind all the algorithms. So not really like you don't have to know, hey, like how like the equation behind a SVM classifier. You don't know like how does random forest work, what is KL divergence. You don't know all this. You just need to know the rough intuition. So things like what is supervised learning, what is unsupervised learning, bias variance trade-off, no free lunch theorem, all these like the intuitions around machine learning. These are the more important ones that you should focus on, right? Of course, if you're someone who really learns things well from ground up, I of course would advise you to go ahead and learn the actual concepts and equations, because that might really help you in your understanding, as it did for me. So lastly, one last thing, I think you should also know a bit of SQL, just because at an internship, most of the time you're not so lucky to really have them hand you a CSV file or like an Excel sheet to analyze and work on. So most of the time you have to query from a database, and in that situation, you don't want to be too shocked when you come in. So you should at least know a little bit of SQL before you start an internship. Right. So now that we talk about the skills and knowledge required, let's talk about how you should go about learning them. So I'm really a big advocate of project-based learning instead of lecture-style kind of learning. So the reason is because let's say when you do a project, you actually know like where things fall into place. So you know like, hey, why do I need to consider what do I need to know how to split a data set into a train and test. You don't really know the importance of all these things until you actually do a project and you see where they fit into place. And furthermore, project-based learning really helps you to like, let's say if you are doing a project on your own, it really helps you to push yourself to think critically and like think about what to do next. And in the process of doing research and solving a problem, it helps you to retain the knowledge better because of the amount of cognitive effort that you put in the first place. Then lastly, another good thing about project-based learning is that after you finish a project, you can, if it's good, you can put on your resume portfolio. So it helps you to bolster your portfolio, so that when you apply for internships, you have an easier time now. So as for the first point that I brought up on the last slide regarding the practical skills, I think I really believe that I really recommend Udemy as a platform in general to learn coding, because Udemy actually like there's really many good teachers on Udemy, but there's one good course that I want to recommend to all of you guys, which is this course over here. I can send a link in the chat later on. So why I like this course so much is because it not only teaches you the packages like from ground up. So like one particular mistake that I really see many people make, which include myself, like that I made, is that I only just learned. I didn't really learn the packages like in depth. I just like, okay, I do this project and I see where it's used. Okay, I roughly know. Okay, pandas can be used to manipulate data, but I don't know how it works. So in this course, they actually teach you like why is there even a need for like pandas or NumPy. So things like, okay, NumPy, what is NumPy used for? NumPy is here to help with matrix operations. So why is there a need for NumPy? NumPy helps you to make things faster due to a process called vectorization. Yeah, so all this kind of thing really helped me to cement the knowledge of the packages, like because I learned it from ground up. Like furthermore, there are many challenges in the courses, like in this particular course, that where you can get a chance to analyze real data set. Like so using there will be like problem Jupyter notebooks with empty code cells. You can actually challenge yourself and do it before you check the solution. So the process of testing yourself really helps you to learn it, like have a more solid grasp of the knowledge. So that is the first thing to learn the practical skills. Secondly, for the theory. I think most of you know Coursera, Prof. Andrew Ng's courses on machine learning and deep learning. They are really fantastic. Like for me, I took the 5 courses on deep learning, and like they really helped me get a understanding on like how should I structure a machine learning project. Like the train test split, like the distributions, how should we split them, blah blah blah, all those kind of things. Then lastly, I recommend someone new to go for many hackathons, because I think hackathons firstly is a way to really push yourself to complete a project. So if it's good, you can also put it on a resume. That's one thing. Secondly, with a hackathon, you actually it actually points out to you like where you which areas that you are good at and which areas that you are maybe lacking. So after that, after the hackathon, once you realize that where you're lacking, you can actually put in more effort to improve yourself in those areas. So it's a good way to really reflect on where you are currently, your current progress. Right. Okay, so now let's say you follow the steps that I showed in the last slide, and you managed to you did the course on Udemy, you understand the concepts, and you went for a few hackathons, and you applied for an internship and you secured it. So now what? Like what should you do now? Okay, so for my first internship, actually I had an internship before my Safemode internship in the summer of my second year. So I thought I was there to do some machine learning regarding facial recognition and computer vision. So that was what I thought. But but the job scope was really big, and when I came in, it turns out that the whole team was more well versed in software engineering and web development. So my job scope quickly like shifted towards a more software engineering, web development kind of role. And I was really in for a shock, because I didn't prepare at all for like software engineering stuff. Like, so I had to cram how to do HTML, CSS, JavaScript, React, all this within a few weeks. And even then, I didn't have a good understanding of any of the concepts. So because I was rushing so badly, and I didn't really perform well, right? So to prevent that, I think like when I secured my internship for Safemode, I actually started Skyping my supervisor, which is the prof and the CTO, on a weekly basis before the internship started. So like firstly I would get a good grasp on like what the internship is about, like what's my exact role, what's my project, like what am I going to do there. So then I would know, then once I know that, I can understand like, okay, so these skills are important in doing this internship. I should focus on them more before I enter, right? So with all this preparation, I actually could complete plenty of tasks on my first few days there. So I wasn't like flustered or anything. Like I was like composed, and I was well prepared. So I think I would like to advise all of you guys to in your future internships to really just try to initiate some communication with your supervisors as soon as you like sign a contract or secure an internship, and really try to understand what the thing is about, like concretely, so they can be better prepared for the internship, and just get it off on a good start, and just get the ball rolling on the first day that you start the internship, right? Okay, so now let's say you started the internship. How should you perform well in the internship? So I think firstly I want to go through like why you want to perform well at all doing an internship. So some of you guys might think, okay, the internship is like the be all end all. It's like once I get an internship, I'm like, okay, I have one already. But actually that's not the case, because I think that's a very short-term mindset, because actually your internship is just a stepping stone to your next internship or your full-time job. It's not the be all end all. And you should always try to perform well, because firstly you can put more things on your resume. I can have more impact and show it and portray it on your resume, so it can be so that future employers can view in a better light. Secondly, if you perform well enough, you can actually request for a recommendation letter from your supervisor, which also helps a lot in your upcoming applications, right? So how should you perform well at a role? So firstly, I think you should take a lot of initiative. So I think many of us, when we first start working, including myself, is that we're just like a I would like to say like a blind worker. So basically, what happens is the supervisor gives you tasks and you just perform. You just try your best to perform it well. Give me task A, I do it well. I go back to my supervisor. Task B, do well, and repeat. So I think that is of course important, and that is like the basic requirements and responsibilities as a worker. But let's say if you want to take it, you want to really be outstanding, you have to take more initiatives and like just keep a lookout for problems before your supervisor points them out to you, and even better, just try to solve them before your supervisor says anything. So I think this really shows that you take initiative and that you are an independent problem solver, which really reflects very well on you. So for me, when I was in my data science internship at Safemode, I was building plenty of models, right? So like after so because I wanted to like see whether this model would give me promising results, right? So I realized that the process of tuning hyperparameters after I built the models was actually very inefficient. So for all of you guys who don't know what hyperparameters are, they're like, let's say a neural network. Like there are things that describe a model. So let's say for a neural network, like things like how many layers that there should be, what is the loss function, what loss function are we using? Things like that describe the model itself. These are called hyperparameters. And it's like the process of choosing these parameters are really very uncertain. There are many. It's like normally we just randomly just come out with some number, or we go like to do like a grid search, like just going through a set number of configurations. And I think it's really like very confusing on how should we pick the next set of numbers to try. So I went to do some research and I implemented this algorithm called vision optimization that can automate the process of the tuning process. So I could just press enter and the thing will do it by itself. And I think that really made the process of building models way more efficient. And not only for me, but let's say when I pass it on to my successor, the next data scientist or the next intern, he can also help him make things more efficient, right? So I think like basically what I'm trying to convey is, firstly, you have to look out for areas that can be improved, and once you have an eye for that, then you can start to put in this extra effort to improve it on your own, instead of just focusing on your tasks solely. Okay. Secondly, you should also communicate with your supervisors and your team regularly, because you're not the only one. You're not the only one working on the project. Like there are like tons of people like working on towards the same goal as you. So and many of them have more experience than you. So you should so let's say if you don't share your challenges and what you're up to now, there is really no chance for them to give you any feedback or any suggestions or advice. But let's say if you share your challenges regularly, let's say some of them they might know the solutions, or they might know a shortcut. They will really offer you. They might offer you a way to really perform your job way better, right? Secondly, I think it's good to give regular progress reports so that your supervisor knows like the direction you're going right now and your current progress. And yeah, but firstly, they can give you advice to correct, let's say if you're going astray, or secondly, they also know that, hey, at least this guy is doing this thing right now. It's like it gives you like a form of he knows that you are not like slacking off, like he knows the things that you're doing, so like it also reflects good on you, right? Lastly, I think you should also keep your code organized and understandable, right? So I think many of us, including me, like we made this mistake. We're just trying to get the job done, right? Like we just want to get the code working, up and running, and like, yeah, that's it. But like we have to remember that, okay, we're only just an intern here. Like there will be someone else taking over our project when we are done at this company. So like I also realized that like a bit too late during my internship. only like around like 2 months in, like when I was like almost called back, then I started to really organize my code well. So how should you organize your code as a data scientist? I think you should always firstly you should keep your code modularized. So implement functions wherever possible, so that ensure reusability. Then you should leave comments that explains why the code is that explains like the purpose of the code itself, instead of explaining what the code is trying to do. So your code should be so clear, that your naming of variables should be so clear that that the person can just understand by reading the code itself. And the comments is there to explain the purpose of the code. Yeah, all right. So lastly, you should also always, I believe, like you should separate your notebooks into like every notebook should have their own one specific purpose. So like let's say one notebook for exploratory data analysis, another notebook to test this maybe SVM model, another notebook to test a neural network model. So you should always keep notebooks like as small as possible and decoupled from one another. So this would really make your code more understandable and easier for whoever's taking over your project to pick up the project, right, after you leave the company. All right. To end off, I think I just want to share some reflections on on my thoughts about data science after my internship. So before I went for my internship, like I always thought of data science projects as more of like, I want to get a job done, I want to get things done, I just want to get the model up and running, I want to just finish the tutorial, I want to fix all the bugs, blah blah blah. It's like getting a job done. It's a very engineering mindset, like hit the specs, right? So however, like I realized when I was doing the internship, I realized that like actually that's only the bare requirement. What is more important, like data science, right, is actually a form of science. So you actually like you have to master the science aspect of data science too. So what I mean is that other than just getting things done, you should a data scientist should be able to set up hypotheses, should be able to first set up hypotheses and then test them out using code, using experimentation through code. So through this process, you actually will gain a deeper understanding of the data set, and using these insights, you can you provide value to the company using these insights. So I think that is the main job of the data scientist, instead of just like creating this model or whatnot. Because like that is more of the job of like engineers, right? Like set up a website, blah blah blah. A data science is really there to provide more insights into the data. So I think having this critical thinking ability and the ability to like think in a scientific manner is really important as a data scientist. Yeah. So with that, I'd like to end off, and thanks. Good luck for your applications. Yeah.
Okay. Thank you so much, Jeffrey, for your sharing. I think it's quite interesting, and in my opinion, I agree with your suggestion that we need to, if we want to learn more for data science, I think the best way is to do it based on project, because from there you can really test out your skills and learn much from it. Yeah. And okay, now let's move on to the Q&A session. Okay, so let's give the chance to anyone who wants to directly ask first before we move on to the Slido. Is there anyone who wants to directly ask? Okay. Okay, so if no one wants to ask, then let's start with a Slido question. Let me pick a question. Okay, so Jeffrey, can you explain the process for the applying process for OEP for data science company?
Right. Okay. So the OEP actually doesn't really, they won't separate applications for whether you are a data science guy or whether you are a business guy. So firstly, you have to go through an preliminary interview that to show that you have some entrepreneurship tendencies, and then after that, you go through a panel interview with the director of the program and whatnot. So I think what they're looking out for is not really grades, but things that show that you have an interest towards entrepreneurship and some skills that make you employable when the startup companies want to hire you. So after you get past the bar on NTU side or NTU OEP side, then you will start interviewing with companies within the countries of your choice, right? So this is quite a so you will get one interview this week, yeah, and another interview that week, and some of them they might have challenges like tests and challenges, so you should be prepared for that too. Yeah.
I see. So
like
it's
for my internship, sorry.
So it's a multiple level, multiple interview. Is it like one?
Yeah, exactly. So
NTU, yeah.
you first have to go through the cut for NTU, then they will interview you and see what you're interested in, and then they will recommend you companies to interview with. Yeah.
Okay. Next one. There is an interesting question. So, do you have any setback or challenges during your internship, and how do you overcome those setbacks?
Yeah, so during my internship, actually there were quite a few setbacks. I could think of two straight from my head. So first setback was for 1 month during my internship. Just for perspective, like my internship was only around 3 months long. So during my second month, my supervisor, the prof, actually, I think his son fell sick and he was like MIA from work, right? So I didn't really have anyone to go to for any directions on my work. So like I would just be doing the work myself, and I would have to think of directions myself. So that really like showed me the importance of being an independent problem solver and just look for directions yourself. Yeah. So what I did was I went cause like many times like it wasn't a very smooth journey when I tried to build my models, right? It's not like I just apply a model straight away, the results were good. No, actually it was not. It was not the case. So my job was to build a regression model, right? But however, the data set that they provided me was actually really too it was not very rich to begin with. So I really that any model would not be able to perform on this data set. It's not the constraint of the model, it's more of the constraint of data set. So that was one challenge that I faced, and what I learned from my supervisor was actually pretty insightful. What we did was we changed the model objective from a regression to more of a classification task. So what do I mean by that? So instead of asking the model to predict like a real value, we ask it to predict just whether, firstly, just start with whether is it above the mean or is it below the mean. So that's like a more doable task for like a less rich data set, and from there you can actually test like the effects of your experimentations. So when you add in more data sources, you can see how well is it improving on this particular metric, and then once it does well enough on this metric, I will increase the difficulty of the task. So it can increase to 3 class, then finally to regression model. So that was another challenge that I learned, another takeaway that I learned from my internship. Yeah.
I see. Quite interesting. So you transform a linear regression model to a logistic regression. Yeah. Classification model. Okay, let's move on to the next question. Is math do you think math is important for ML internship? You need to
Actually,
really
I think
understand.
I think math is important. I think it's definitely like it plays a part to your success in an internship. But I think like what I mentioned during the presentation, I think 80% of what you're doing is mostly data manipulation and visualization, depending on your internship. But yeah, that would be most of what you'll be doing. So as long as you have that covered, I think you are really set. And the math things you can actually learn it either on the job, or you can even ask your supervisor or your colleague who may be more experienced and have more intuition on the math side. But of course, if of course it'll be good that if you have a better understanding of how algorithms work. But what I found for myself is that even though I know like what the equations are, it still doesn't beat like testing them out on real data sets. So after running them, or after running like different models on like my online data sets, I found out that hey, uh, random forest actually works very well for small data sets, right? Better than SVMs, better than neural networks. And gradient boosted trees actually they produce very good results, but they tend to overfit. But this kind of thing, I think you this kind of insights you normally gain through practice and experimentation, and it can't really be drawn from just understanding the math alone. Yeah.
Yeah, and I think you need to learn more also on the coding, I think, because if you need to implement it in a programming language, right? And okay, so next question. Okay, since you and I are triple E students, and for triple E students, since we are from engineering background, right? So is it hard to get a data science internship, and how do you become interested in data science? Since
Okay, so the question was, is it hard, and like how did I get interested? So I think so firstly I want to like answer like how did I get interested. So firstly I think back when I was in my first year, I took some intro courses into programming, and I think I really found that I kind of like software. I didn't really like dealing with like hardware tools, so I already had I already had some sort of interest there. And then like back then when I was in my second year, like it was really AI was really like the in thing, just like it is currently right now. So like my curiosity kind of led me to explore it, and I just thought, hey, why not? Yeah, so that's what like I thought like why not, and like see how far this can get, right? So that was my mindset, and what got me started. Then on the question about is it hard for a triple E student to get a data science internship, I think no, actually it's not. Even though you have to put in more work than let's say someone with a computer science degree we need to, but actually we actually also like okay, like anything, like any job that you want to go into, right? The skills that you need on the job are different from things that you learn in school. So the things that we learn in school are actually not very relevant. But like so you do have to put in the effort to learn things and foster your portfolio by yourself. So you have to know like what your so to be able to secure an internship, you need to know like what your employers want you to do. So I think employers really need want interns to help them solve problems, and really just do from day one. Like gone are the days where we get internships to learn and whatnot. I think now we should come in with the mindset that I'm here to help the company, right? And then the company will be, of course, glad to hire you because you're there at a cheaper price than full timers. And let's say if you have some expertise, you'll be actually quite an attractive hire. So as long as you prepare yourself well and you have the skills to perform on the job through like projects, courses, and what I recommended just now, I think no, like you won't have any issues finding an internship as a triple E student.
Yeah, I think the key is that you need to put on some effort to actually learn the data science by yourself. But it's not too hard actually if you have the interest and you put some effort.
Exactly. So like once you learn them, you need to show your supervisor, you need to show your employers that you are able to help them solve problems. Yeah, I think through a resume and your interview and whatnot. Yeah, that's what you want to communicate to your employers. Yeah.
Okay, so another question is, okay, so what do you think is a good choice for third year or final year elective if you want to take ML related jobs in the future? Like what triple E electives that you think are the most suitable for ML related jobs?
Okay, I'm not very sure how to answer this question because I actually went for exchange during my year 3 sem 1. But like actually I would say it doesn't really matter, like in my opinion. Like this is quite a like it's not very relevant. Because if let's say you want to get a data science internship, you should just go and learn it through the material, like directly through the materials directly, like courses, and they teach you directly what data science is about, and not like try to learn them through school AAA courses which are maybe not related, right? So I mean the most related things are like the math courses, and like the more mathematical it gets, the better it is, because it prepares you to understand like the hardcore math of ML. And I guess that would be a good answer. Yeah. But it doesn't really matter in my opinion.
Okay. Okay, last question before we move on to the next speaker. Okay. How long was your overseas internship, and how do you cope with the overseas situation and with the internship?
So my internship was supposed to be like 6 months long. Then I would finish off with a summer school in Technion, a university in Israel. So however, this was all that was the plan, but this was all cut short due to the COVID scenario situation. So that's that. Then on the question of the overseas, how do I cope? I'm not sure what you're trying to ask. Do you mean more of the COVID, or do you mean like in general?
How do you cope with like the maybe cultural shock, or how do you cope with the situation? As a overseas, as a foreigner and doing internship in an overseas company.
Right. I think the culture shock. I think the culture was the change in culture was actually more of a good thing than a bad thing for me. Cause I really got to see like things from a different perspective. So firstly, I think my colleagues were all very welcoming, and they really put in a lot of effort to show me around, tell me like where the places to go. Like before I even started, my CEO like texted me to help me to offer help to find a good housing and stuff like that. So I think that was pretty good. But for the culture wise, definitely there are like literally no Asians there. Then like food wise, you have to adjust. You have to buy your own groceries, cook yourself. But the culture actually was a very eye-opening experience. So like in Singapore, like there's actually not much emphasis on entrepreneurship. I want to say not much emphasis. Like the culture here is still more tuned towards the corporate world. Like the people's dreams are all like, hey, I want to work at Google, I want to work at Facebook. That is like the highest aim for students currently. But in Israel, actually it's the other way around. Like people view entrepreneurship as the highest prestige. So like what I mentioned just now, many PhD graduates, they would choose to actually be a founder rather than go work for like Google or whatnot. So that is one. And actually another thing is that Israel actually has a lot of deep tech startups. So that was actually one thing that drew me to Israel also, because like there are people there they really love learning, and they really like many of them pursue like postgraduate studies. So it's not uncommon to see people like working adults like part-timing, doing a part-time PhD or part-time masters just for the fun of it. Yeah. So that was also a very interesting experience. Yeah.
I see. Yeah. Okay. Okay. First, thank you, Jeffrey, for your sharing. We really appreciate your sharing. Okay. But before we move on, let me answer some of your questions regarding MLDA. Okay, so yeah, so for students, for year one students who want to join MLDA, we will have a separate recruitment process in around week 1 or week 2, because we want all freshmen to come to NTU first. Then definitely IM can join MLDA because IM is part of School of Triple E. And then yeah, this Zoom meeting will be recorded, and we will upload it to our YouTube channel, MLDA. Later we will talk about our social media. Yeah, so you can watch it in our YouTube channel afterwards. Okay. So now let's move on to the second speaker, which is Khai Xiang. So he is a PhD student in integrative sciences, and today he's going to share more about his current work. Okay, let's welcome Khai Xiang.
All right, thank you. Can everybody hear me?
Yes, I can.
Yeah, okay. All right, so thank you all for spending your evening with me. I'm Khai Xiang. I am a third-year PhD student. My PhD has to do with computational statistics, some algorithm, things like that. And interestingly enough, my experience was quite opposite of what Jeffrey showed just now. So Jeffrey, I think he said he picked up ML and related topics in his first or second year. Before my PhD, I was an engineering student in NUS. I did engineering science, which basically is some physics, a bit of engineering, some applied mathematics, and I didn't know much about machine learning or data at all. It is actually after when I graduated that I took the time to learn, and then I did all the courses, about maybe 5 to 8 of them, all in a short period of time, and I just really enjoyed it. So that brought me to explore deeper into machine learning, statistics, and eventually what I'm doing right now. Okay, so now let me share my screen. Okay. Yeah. All right, so in this talk, I won't be sharing so much specifically about the research experience or how to get into research or what it is like. I will touch on those a little bit, but for the most part, I think what is more interesting is the research itself. So today my talk is titled Uncertainty and Bayesian Inference, Why Machine Learning Cannot Help You. And it's a bold title, and if it sounds like a clickbait, it's because it is. When I say why machine learning cannot help you, it's not strictly true. But later, hopefully, I can explain that it is in some sense true that the traditional machine learning methods are simply insufficient for today's demands. And if you notice on the picture that you're seeing here, there's a little picture in the background. It looks kind of strange, like a map of some sort. And hopefully by the end of this talk, you will know what it is. So let's just consider a hypothetical situation where if you have a glass of water and you turn your head away and someone drops a drop of ink inside, and expectedly the ink is going to diffuse, and if you look back 1 second later, you see it diffuse, and the question is, where did the ink, which part of the drink was the ink dropped into? So you might make a guess, right? You can see the spread pattern, and you can make a guess where it's from. But imagine if you repeat the experiment by looking away 10 seconds this time, and when you look back, the ink would have diffused more, and it's a bit harder to tell where it came from. And of course, if you look away an hour, when you are looking back, all the ink would have diffused completely, and you would not be able to tell where the ink came from at all, because it's just going to be homogeneous everywhere.
Sorry, the screen you're not sharing.
Oh dear. Am I not? Oh. New share. Oopsie daisy. This one? Hold on. Am I not sharing my screen here? Is this shared?
Yes, I can see.
Can you see the ink?
Yes, yes.
Okay, so sorry. Sorry for that. But well, okay, you didn't lose much. It's just a picture of an ink. So there you go. So the point that I'm trying to make is that there are questions that when you solve them, there's going to be uncertainty. And in this question, it is clear that the longer you wait for the ink to diffuse, and when you try to infer later on where the ink came from, it's going to be harder and harder to do that, right? So this is an example of how uncertainty naturally arises in nature. So here's another example. So this is the temperature of the world taken from NASA, I think. And take a guess, how do you think they arrive at these measurements? So you can imagine maybe there are a couple of thousands of temperature measuring thermometers around the world, satellites, whatever. But surely you can't have enough to cover the entire Earth, right? So how do they know? How do they create this map, right? So the simple answer is that they estimate, right? If you have a temperature measurement here, and then you have another measurement here, you may want to estimate what is going on in between, okay? And naturally, there's going to be variations. There are more than one ways you can connect two dots. And so, it can be connected in different ways, and not all the ways are going to be treated equal, but nevertheless, the idea is that there is uncertainty. And that is very important, and that is what we're going to be talking about today. So why should we care about uncertainty? So I've explained a few ways uncertainty arise in nature and in real life, but why do we need to think about it so much at all? After all, most things in life we might be able to say with a lot of certainty. Like I can say right now I'm sitting on a chair and I'm saying that the chair is not going to collapse right away, and it didn't, right? So it's a non-zero chance it might, but I'm very confident that it won't. So in this case, in machine learning specifically, so here are some cases where having uncertainty estimates to your measurements, to your algorithm outputs is going to be very important. So in 2015, a photo application mislabeled two African American users as gorillas. And if you think that this is, this is just some company making a mess up, no, it's Google. So these things do happen when your algorithm isn't sure or it messes up, but it doesn't tell you its certainty. Another case, so we have the first casualty of the driver of self-driving vehicles. This is really unfortunate. It happened a couple of years ago. And again, this is Tesla. So it's very, very important to be able to know how much to trust the outputs of our machine learning, our neural networks. And of course, in our day-to-day life, we sometimes see doctors and we want to know, for example, when the doctor makes a diagnosis, how sure the doctor is, right? There's a difference between you have cancer for sure and you have cancer maybe, right? And of course, you can extrapolate this idea into real life. If you ask your girlfriend or boyfriend, do you love me? And he or she says yes, there's a difference between yes, sure, and yes, kind of, right? So uncertainty is important. And hopefully this convinces you that we should always be thinking about it, and we should always be thinking how to know how much to trust our answers in all these machine learning algorithms. So just to give a brief example, so this is a basic regression problem in machine learning. It's part of a supervised learning problem. So just to briefly describe it, you have some black dots. These black dots are part of the points on these red lines. So in reality, you don't see this red line. This red line is what you're trying to guess. All you see are the black dots. And the algorithm, in this case, is a neural network. Neural network guesses that the data is connected by this teal line here. So you can see it's not a very good estimate, but that's not a problem, right? Because after all, you're given very limited data. This is the best you can do. That's fine, right? But the problem is, it gives you one answer. It tells you that, okay, this is my best guess, and that's that, right? You can see that when there's no data, maybe on the left or right region, the guess is quite wrong, right? But the machine learning algorithm in this case will tell you all the same that this is what I guess, with no idea of how sure the machine learning algorithm is. Whereas what we are hoping to achieve at the end of this is something like this. is a Bayesian neural network in a sense. It is a type of machine learning with uncertainty. So we can see here, clearly we can see that when there's data where there are the black dots, the teal lines are very tight, scrunched up together because they are very certain. They are very sure that it has to pass through these dots. When there's no data here, it is a little bit more looser. And of course, when it's far away from data on the left and right edges, you can see that all these swings shows you that the algorithm is really not sure. So that's why it says it's maybe here, it's maybe here, it's maybe here, maybe here. But that's what we want, right? We are not looking for necessarily the algorithm that tells us what's the best thing or what's the most you can do out of the data, but I want to know also how unsure you are, right? And I can take that into my decision-making process as people. So this is regression problem from a supervised learning. Another example that is quite common in machine learning is unsupervised learning. In this case, it's a clustering problem. So for those who are unfamiliar, a clustering problem is quite simple. It is to say that starting from a bunch of dots. So in this case, you can imagine all these dots to be black and all the same, right? I want to guess how many clusters there are. And this is the output here. You see, this is the output of the algorithm. It tells us that there are 3 clusters, right? The triangle yellow cluster, the blue circle cluster, and the gray square clusters. So that's just the goal, right? To tell you how many clusters there are and split up the data into the clusters themselves. Again, when we include uncertainty, this is what we hope to see. We want to see that each of the data which we judge to be from a certain cluster, we want to know how sure the algorithm is. Are you sure it's from this cluster, right? Are you sure it's from that cluster, right? As later you will realize that you will never get 100% certainty. So everything you decide must come with some type of uncertainty estimate. Okay, so hopefully this convinces you that uncertainty can be very, very helpful depending on your application. And it's certainly, as an academic topic, very, very interesting. You're thinking about probability and things like that. So now we move on to how do we capture uncertainty. We have our machine learning algorithms, right? Maybe your linear regression, your logistic regression, whatever. But if you just apply them wholesale, you're not going to get an uncertainty estimate. You're going to get a point estimate. So this picture here kind of sums up the feeling that I get when I first learned about the topic. So this, I'm not sure if many of you recognize this. This is from the movie The Matrix. In this scene, the main character, which you can see from the reflection of the spoon, sees this spoon bending, and the child tells the main character that do not try to bend the spoon, it's impossible. Instead, realize the reality that there is no spoon. So if you don't know what that means, I don't either, but it sounds cool. And I guess maybe the underlying message in this case is to say that, to realize that there is actually no such thing as 100% certainty. Once you realize that, you kind of maybe it makes more sense to think about every answer, what is the uncertainty that comes with it. So the key is to think about probabilities instead of point estimates. So everything you have, your unknown variables are now become random variables, and your output, your answers, instead of a point, a certain number, it is a probability distribution. Okay? So let's think a little bit more about that. So just to quickly give a refresher, if you will, we need to talk about conditional probability in this case. So this is how we call it. So we have this P here, this is probability. So this symbol P, X, Y, we read it as probability of X condition on Y, or probability of X given Y, right? So it's the probability of X happening given we know Y happened. So just to be clear, probability of Y given X is not the same as probability of X given Y, right? When you swap them, the meaning changes, right? They are not symmetrical operators. So just a quick example. So the probability of rolling an even number, if you roll a dice, given you've rolled a 6 and the other way around, okay? So given you have rolled a 6 already, the probability of rolling an even number is 100% because you have already rolled a 6. 6 is an even number. Whereas the other way around, if you rolled an even number, what is the probability that it is a 6? Now that is only a third because it could be 2, it could be 4, it could be 6, okay? Another example is this. So the probability of you doing a happy dance when your crush smiles at you, which is pretty high, I would say, versus the other way around, which is that you randomly do a dance and your crush then smiles at you. This almost never happens, not in my experience at least. And lastly, something more relevant, it is that the probability of you having fever, given you have COVID, versus the other way around. Now, if you have COVID positive, then there's a high chance that you have fever. It's one of the symptoms. But if you have fever, it doesn't mean as much because fever is quite a common thing, so you might not have COVID, right? So these examples hopefully shows you obvious enough that PXY is not the same as PYX, and we need to be very careful about this, right? So just to caution you guys, when you guys looked up online, when you fever and you Google WebMD, what do you have? What you're checking is actually here. You're checking the symptoms, whereas what you want to find out is the probability of a disease given a symptom. It's not the same thing. Okay. All right. Now we kind of move on to the meat of the topic. Here is the only equation you will see, so don't worry too much. So what we are talking about here is Bayesian inference. So essentially, here's what we do. We want to find out the answer, in this case, I call it theta, okay, given some data. All right. And this equation tells us how to get this quantity on the left from these things on the right. Let me explain them bit by bit. So here we start with the prior. This prior is our initial belief of the answer that we have. So maybe in the case of a linear regression, maybe you want to figure out some coefficients of your equation and like an intersect maybe. And the prior is what we believe it to be. So this is purely what we choose as users. If you believe it to be maybe you believe it to be maybe a Gaussian distribution centered around 1, then let be that. And so you can choose this. And the next thing we have is the likelihood. So this is where the data comes in. So now you're thinking, given what theta is, how likely it is for me to observe the data, right? In a moment, I will show you a nice simulation to make that clear. And lastly, we have the evidence term on the bottom, which serves to normalize the entire expression so that it becomes, so that they sum up to 1. In other words, it's a probability distribution. And at the end, we get out the posterior distribution. So essentially what this equation is trying to tell us is that we started with some belief. We want to incorporate data that we observe into the belief and update our belief. Okay, so let me show a bit about what it looks like. Okay, I think you guys can still see it. So this is a really nice website. So I'm just gonna show a simulation. So in this case, the question you're asking is a coin fair, right? So if you see a coin, you don't know if it's fair. Maybe it's trick coin, maybe it's not, right? So what you do is you flip it a bunch of times and you see the output, right? So let's say that secretly, let's say I set the coin to be this, meaning to say there's a 0.31 chance of it turning heads. Okay, and then this is my initial belief. So let's say I set it to be like this. Okay, so I believe, so clearly when I say what I believe, it's over a certain range of values, and I believe that it's likely maybe somewhere here. That means I believe this coin is unfair, but it might turn up heads up maybe about here is 0.8% of the time. And now I start flipping the coin. Now as I flip the coin, I look at the data and I update what I believe, right? So the coin, so you can see, as I flip the coin, I'm gonna keep on updating my belief. And how you update this belief is by the Bayesian equation that you see just now. And if you notice, as I flip the coin more and more and more, my belief gets closer to the truth. And that is the power of a Bayesian framework, is that you are able to incrementally update your belief according to data. Now we can flip the coin 10 times in a row, and you can see it's going to get closer and closer and closer. So surely it's not going to be perfectly aligned with the truth. But the point is, notice that your answer now is not just one value, it is a distribution. It is a distribution, right? So we can keep on doing this until we're happy. And then when we feel like stopping, and then we go, okay, so this is what I decide to stop. So in this case, I think it's going to stop sometime, right? So you can see that starting from our initial belief, which is here all the way on the right, when we observe data, we update our belief slowly, 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 and approach the truth. And that's the whole point of a Bayesian framework, right? So again, in real life, you wouldn't see this pink line. You wouldn't know what the truth is. This is something that you want to guess, or rather you want to learn. And through this equation, this very powerful yet simple looking equation, you can update your beliefs. Okay. So from this, it is quite straightforward, conceptually at least, that we want to extend this to all of our machine learning techniques. Ideally, we can do that, right? So we, instead of logistic regression, we can have Bayesian logistic regression. Instead of linear regression, we can have Bayesian linear regression, Bayesian clustering, and everything like that, right? So the end product of the Bayesian inference is a posterior, which is a probability distribution that describes the uncertainty of the quantity they're looking for. Okay, so that is the end of the Bayesian inference, the equation at least. So now we need to think about what we want to do with that probability distribution. So giving you a distribution is nice and well, but if you need to know some information, it is far from straightforward. So in the previous example that I showed you, if I just show you one-dimensional probability distribution, it's very easy to understand because we can see it, right? It's just, oh, it has a peak, maybe it has two peaks, whatever, but it's easy to see. But in real applications, rarely it is so low dimensional. The posterior usually you'll be facing is high dimensional, maybe a couple of tens or hundreds or thousands, in dimensions that which we cannot visualize at all. In those cases, what does it really mean to say that I have a posterior distribution without knowing anything or any type of visualization, right? So in some sense, we need to measure the posterior, we need to get to know the posterior. Maybe you want to know the expectation, the mean, the variances, different moments of it, right? So this is where my research kinds of start, which is that from a Bayesian framework, we have a posterior, right? We have a prior, we update it with our data. We have a lot of data, we update it, and then we get a posterior. So there are two main strategies to investigate the qualities of a posterior. First one is called the variational inference. I will not be going into this because this is quite a different topic on its own. It's a huge topic, but just to briefly overview it, the idea is that if you have a very complicated posterior, you can picture a mountain with very complicated terrain and contours. The idea is that you want to estimate, you want to approximate this posterior with something simple. And the work being done here is that you put in a lot of effort to get a good estimate. So once you have a good estimate, things become easy because now you're only working with something that is very straightforward. And what I'll be talking about today is Markov chain Monte Carlo, right? So what it is a method of taking the posterior and generating samples on the posterior. And the challenge when you're doing that is that you want to be able to do this very efficiently in high dimensions, and it's not very straightforward how this can be done. Okay. So once again, starting from a posterior, the goal of Monte Carlo, Markov chain Monte Carlo, is to construct a Markov chain on the posterior in a sense, which will explore the posterior. So the analogy here is that imagine you are standing on a hill in the dark where you can't see very far anywhere, and you want to be able to walk around the hill and be able to walk around long enough such that you kind of understand what the hill looks like. So clearly, the longer you walk, the more places you would explore, right? And you want to use that information to really reason about the posterior. So here is a really nice simulation to really explain what I mean. So maybe let me start out something like this. Okay, so this is essentially what Markov chain Monte Carlo looks like. Okay, so what this guy is doing is that you can see there's this little circle. This is the sampler, and it is making random moves every time, right? And sometimes you can see it's green, sometimes it's red. When it's green, it accepts the step. When it's red, it rejects the step. So how this is being done, I won't explain in detail because it's where the mathematics lies and it's a little bit complicated. But fair to say that this thing is trying to explore something. It's moving around, right? And the theory tells us, interestingly, that if you follow just some simple rules, this little sampler, given enough time, is going to go to all the places the appropriate amount of time. Meaning to say where there's more density, where there's more probability, it will visit it more often. And where there's less, it will visit it less often. Right? So if we speed it up, you can see this is trying to move around like this. And of course, right now we don't know what the answer looks like, but if we look at the answer here, you can see that it's trying to actually explore this kind of banana-shaped probability distribution here. Okay, and just to show, there are many types of samplers, and the goal is to make things efficient. So if you're familiar with a bit of math, when things are in high dimensions, there's a curse of dimensionality. So when things go in that direction, your sampler becomes incredibly slow and inefficient. So here, this is a different type of sampler. So you can see this sampler is a little smarter. It doesn't take one step at a time. It goes around in curves and tries to take distant steps so that it can visit distant parts of the mountains, and this makes it very efficient. So if we speed it up a bit, we can see that this is what it's trying to do. Maybe you can do this. Yeah. Okay. So this algorithm is called the Hamiltonian Monte Carlo. So the first one you saw was called the random walk, and this is the Hamiltonian Monte Carlo. So I'm going to omit a lot of details here, but the main point is that the goal, starting from a posterior, is now that you're thinking about geometries, you're thinking about how to move around geometric surfaces and geometric objects. Okay. So again, there are a couple of examples, popular ones. We have random walk, we have Hamiltonian, we have Langevin HMC, MCMC, sorry. Yes. So the last bit of what I'm about to share is just what I personally have been working on for the past couple of months. And this is the constrained Hamiltonian Monte Carlo. So if I just kind of show you a little bit about the problem here. So if we choose a different, so in this case, you're looking at a donut, right? And it's pretty clear that according to this, you can see that a lot of the time, because the arrows are so big, they're oftentimes going to step outside of this blue region. And this blue region is where you want to explore, right? So you don't want that, right? You see, it's getting rejected. There's a lot of red because it's too big. And the way to solve this is to shrink the circle so that it only makes proposals and it steps around only within the blue region here, right? So this is all well and good, but the drawback is that this is very slow. This is very inefficient, right? Look at it, it's going only this little region. It's going to take forever until it reaches the entire circle. We can choose a more efficient sampler, but nonetheless, you can see that it is still kind of getting stuck, getting tightly constrained in that little region like this. So that's the problem that I have dealt with in my first piece of work. And essentially the idea is this. So you can see this dark blue region here, and it's really, really tight and it's hard to move around. So what my research group proposed is to project things into a 3D dimension, into a third dimension in this case, and move along on this cylindrical surface. And now you can move along quite freely because you can move in up and down, right? You can move on the surface, and all you really need to worry about is how to stay on that surface, because now you're kind of in this third dimensional object. So this is the constrained Hamiltonian Monte Carlo. If you want to know more about it, feel free to talk to me afterwards. But for now, yeah, I think this picture is enough to describe what it does. Okay. So this brings back to what I spoke about right at the beginning, which is the Bayesian neural network, which is this picture that you saw before. I understand there was a lot of content in a really short amount of time. We started off with uncertainty, then suddenly we have probabilities, and suddenly we are talking about Markov chains, and it's a little bit strange. But to put things compactly, this is the product of a neural network when I apply Markov chain to it, when I apply the constrained Hamiltonian Monte Carlo, which I've been working on it. So this means to say that instead of having one teal line that I look for, which is a product of my neural network weights, which is the settings of my neural network, now each of the settings is now random. And what I want to do is to learn the probability distribution of each of those parameters, each of those weights. And once I have those posteriors, those probability distributions, then I just let my sampler go explore around, and this is the goal. This is kind of the output of the exploration, where you have regions of high uncertainty, regions of low uncertainty, as such. And this kind of nicely, in this case, you can see it encompasses the real line, the true answer, so to speak, which is the red line over here. All right. So that just about wraps it up. To conclude, yeah, we went through why uncertainty exists and why it's important to know that. And then we kind of shift to the mathematical side of things and talk about what it means exactly to be uncertain and how do we describe it using mathematics and how do we get to know it. And lastly, we end up with a bit of applied algorithm here, which is the MCMC. So even though the description of the problem that I started out with is about, machine learning, self-driving cars, and medical diagnosis, whatnot, as a researcher on a day-to-day, what I think about actually is how to explore a mountainous region, how to stay on surfaces. What do I do when my sampler can't move very well, right? So, and that is what research really feels like, is that you are digging into a very deep topic, into a topic very in-depth, and that the picture that you're seeing in your head is usually quite different from the very surface problem that inspired it. And even though in research you are working in a very niche topic, it rarely is the case that you actually only use very few of the things you learn throughout your education. So in this case, my research has brought me to use probability statistics, and how the sampler moves on the surface depends on the geometry, depends on the mechanics, which comes from physics. You use thermodynamics and information theory, which talks about heat and chaos and randomness as well. And these questions often appear in ordinary differential equations, partial differential equations, and you still use a bunch of tools like ergodic theory, how to approximate algorithms, and how fast your algorithm runs. You need to think about all of those things. So in fact, to be very niche and to work on one specific topic does encompass a wide range of skill set. So, and that is something that I find really interesting about research. And if you yourself share the same type of interest, which is to just explore around different academic topics, maybe research is something for you. So I promise that hopefully at the end you will know what this picture is, and yeah, the answer is this is a picture of a random walk. So if you leave a sampler alone, given some distribution, this picture emerges in this case, and I think it looks pretty good. So yeah, thank you for your time.
Okay. Thank you. Khai Xiang. Can you mute because the feedback is quite.
Oh, sorry.
Okay, thanks. Okay, thank you, Khai Xiang, for the sharing. Okay, so now let's move on to the Q&A. Okay, anyone wants to ask directly? Maybe about, it can be anything, maybe about PhD or Bayesian inference or, yeah. Okay, let's just move on to the Slido. Okay, first question, there's a question. What will you say is the future for Bayesian inference? Do you think Bayesian inference will replace the traditional frequentist method, or yeah, what's your opinion on the future for Bayesian inference?
That's a really good question. And so for those who are not familiar, so frequentist is kind of what you've learned in school, in high school, for example, A levels. So that is, yeah, the frequentist method, and the Bayesian method is what I described. For sure, frequentist method are still very, very important. Just to give a very brief example, let's talk about maybe something that happens once off, right? So maybe the elections or something like that. When you discuss things like that and you have a probability distribution, what does it really mean? Because you don't have multiple trials, it doesn't make a lot of sense to talk about many things that you can, many events that you can repeatedly trial or you can test out when it happens only once. So frequentist methods are still gonna be very, very important. But there has been a lot of attention going on in the past years to try to incorporate uncertainty estimates, which comes from the Bayesian methodology, into a lot of what people do beyond, artificial intelligence, just general machine learning and inference in general. I don't think, so in short, I don't think it will replace frequentist methods. And there are a lot of challenges to make Bayesian methods work. They are quite difficult to work with sometimes, and they're quite expensive to run in terms of algorithm. So if you need something quick and fast, maybe that's not the best thing you need for your application. So it won't replace it, but it has been growing in popularity, yes.
I see. Interesting. Okay. Yeah, and
I see
what do you think is the difference between the current ML techniques and the Bayesian ML? Like maybe like the pros and cons, and why current ML, the traditional ML techniques is still more popular for now than the Bayesian ML?
Okay, so to put things in good perspective, what I described is not a new thing, right? So the Bayesian technique has been around for at least the past decade or so. It's been very popular in the past decade, around a little more than that maybe. And of course, the Bayes algorithm, all these things came around in the past 50, 60 years. It's nothing new per se. But I think it's still the general idea that if you're not exposed to this type of ideas, it might be quite surprising to find out that things can be done this way. And if you are learning machine learning in the first few courses, typically you might not have come across these things. Sorry, what's the question again? Sorry.
Okay, so the question is, what's the difference between current ML techniques and Bayesian ML? Maybe the pros and cons, and why traditional ML techniques is still more popular than the Bayesian ML.
So again, very good question. I guess the drawback in applications for Bayesian techniques is that, again, what your output is not one answer, it is a distribution. So maybe from a distribution, if you want a best answer, maybe you take the mean. So it depends on the distribution, of course, right? If you have a normal distribution and you take the mean, what you get is if you get some type of a mode or some type of center estimate, right? But if you have a distribution with two peaks, like a bimodal thing, and you take the mean, it doesn't mean much in the center, right? So depends on what your understanding of the distribution is. You can do different things to explore what it means. You can take the mean, maybe you can talk about the variance, the spread of things. And this is something that frequentist method don't have, and also they don't have to worry about it, right? All you get, you just get an answer. Like when you do linear regression, least squares method, right? You kind of optimize your log likelihood, whatever, you get a number. You just get a number. What that number is, the maximum likelihood estimator. So that number tells you that's the best you can do. And even with a posterior, that could be the most likely answer from that posterior, right? So it doesn't tell you different thing. It's just that one tells you uncertainty and one does not. And depending on your usage, you might not need uncertainty sometimes. Yeah.
I see. Okay.
I see some questions in the chat. So I think I can just answer those as well.
Okay.
That's it. Okay, from Zhang Zeyu. How is my background in physics related to my research? And are things like statistical mechanics related to statistics, machine learning. So my background was engineering science. I did a bit of physics and stuff. I wouldn't say it directly helps me on a day-to-day, but having experience in such areas and such ideas makes it certainly easier to access certain literatures and learn new topics. Specifically, statistical mechanics is a very interesting topic, and it is actually quite related because you're oftentimes thinking about the entropy. So I'm not sure if you guys are familiar, but entropy essentially just means, in the physics framework, it just means the energy that has been used up that is not available to do work, right? So there's things, it relates to chaos, and fundamentally, you might be surprised to find that it is the exact same piece of mathematics that is used in information theory. So information theory describes how much information and how do you encode information into a certain piece of data. Yeah, so they operate on the same mathematics that is due to Claude Shannon, yeah, who's widely known to be the father of information theory. So it is very much related. Yeah, it's one of those relations that is actually really helpful to know both sides of the story. Yeah.
Okay, before we continue, so anyone who wants to ask questions, please post your questions in the either Slido or you can ask directly, so everybody can see your questions and maybe they can upvote like your questions. So yeah. Okay, moving on to the next question.
Oh, there's so many. Yeah. Wow.
What do you think are some of the practical problems that Bayesian neural network might solve better than other algorithm? I think this means normal neural network.
Okay, so based on my personal experience, I haven't explored a whole lot with things like convolutional neural networks and things like that. But what I understand is that let's just talk about the simple example of the face application just now that I mentioned. So if you classify people, let's say if you classify people or if you classify anything and you have a classification, maybe it's a dog, it's a cat. And if you mention this is a dog and I'm 80% sure versus this is a dog, I'm 20% sure. So having that information, in those cases, it is quite important to be able to avoid things like, you know, mislabeling humans as animals and such like that. And in the driving car incident, it is the case that because the sun is so bright that the neural network didn't see the side of the road, which was, I think, also white in color. And therefore, it kind of just made a wrong move. And yeah, someone got really, really badly, someone lost their life in that case. So in those cases, when you don't see anything, I should assume that it should come with a lot of uncertainty because you just don't know what it is over there. The sun is shining too brightly for you to identify anything. And if you're uncertain, it would make sense to then employ further techniques to figure out what to do, right? And of course, in certain cases, the uncertainty themselves can guide your decision. So that is quite interesting. So for example, if you have maybe a curve that you're trying to fit, and then there are some parts that are more uncertain than the others. And if I ask you, now you are given one more data point, right? You can pick where you want the data point to be, but where do you want it to be if I give you the luxury to pick? And of course, you want to pick it at the point where there's the most uncertainty, so that when you have data over there now, the uncertainty in that particular part is going to shrink, right? So you can make use of your uncertainty estimates to drive how you collect your data as well. And this is just kind of right off the top of my head. There are countless uses, especially in the natural sciences as well, in a lot of biology and chemistry research and physics as well, that uses uncertainty. And yeah, so I've only been limited to talking about uncertainty that kind of arises because of some external factor, because of noise or we can't see or no data. But there are many problems where uncertainty is part of the problem. it's a very part of the nature of the problem itself. If I just maybe show you, I don't know if you guys like this, but here's an equation. This is x squared plus y squared equals 1. So for those who are not sure, this is the equation of a circle. So if I show you this and I ask you what is y or what is x, you can't tell me because they are related to each other, right? What you can tell me is how the two are related, which is you draw out a circle themselves, right? So in this case, if x and y are treated as one object, x, y, there's no one answer inherently because of the way the problem is set up. There's just not enough information. There's two equations, there's two unknowns, and there's only one equation. You can't solve it uniquely. So in those cases, so the problem itself poses uncertainty, and this is, I think in this case, it's called non-identifiability. So it's part of the nature of the problem, in fact.
Okay, interesting. Okay, last question. Okay, it's quite unrelated to the Bayesian, but there's someone who asked, why are most distributions modeled by a Gaussian distribution?
Okay.
What's your opinion on that?
Who asked this question? I'm interested to find out. It's a really good question. So essentially, for the uninitiated, the Gaussian distribution is your famous bell curve. So bell curve is something that arises quite often in nature, right? If you plot out the histogram of the height of people, it will be a bell curve. The weight of people will be a bell curve. Many things will be a bell curve, but certainly not everything will be a bell curve. Okay, and that's obviously something that people assume a lot. So the short answer to assuming most things are approximated by bell curve is it's not a good answer, it's the answer. The answer is that because it's easy to work with. Because when you write down the mathematics of it, most of the times, other than some distributions that we have a good understanding of, like the exponential family and things like that, you can write down the math easily, right? There are things that you can cancel out and all the nice math works out so that your final algorithm is clean and easy to work with, okay? This is definitely the case for variational inference. Recall what I said is that you're trying to approximate a very complicated procedure with something simple. And oftentimes that simple approximation is the normal distribution, the bell curve itself. So what we result in is, in fact, a qualifier in the sense that if your application is wildly different, it might not work that good. There is some confidence that we can say that many applications will work fairly well, especially when it comes down to noise. If you consider your data is uncertain because of noise, a lot of time it is fair to represent it as a normal distribution, that it's a Gaussian noise. But it's, in short, mathematically speaking, it is very clean and easy to work with. We have a lot of ways to deal with it, but you're definitely right. And there are many people working on using non-Gaussian methods. In this particular talk, I'm assuming most things are Gaussian because it's kind of more easy to understand. And depending on your research, it might not be super important for you to do non-Gaussian or avoid Gaussian just for the sake of it. So for example, my goal is to explore a posterior efficiently, right? So for example, if you consider a distribution with two modes, right, like a bimodal thing, it's very hard for the sampler to walk from one mode to the other mode, right? That's a very hard problem because in between it's going to be a very low valley, and that's not good for the sampler. But my research is not exactly to do with how to jump from mode to mode. So if you're working on that, then of course you want to assume different things. But my research particularly is focused on how to do it efficiently on one mode, for example. Yeah, so research-wise, they have different simplifying assumptions for different purposes, yes. But indeed, in real life, most things, not a lot of things are very Gaussian, and many things are not Gaussian. And yeah, so in those cases, you want to change your assumptions, you want to change your priors, and that will result in different posteriors on which you can still, of course, apply your Bayesian methods.
Oh, sorry, I was muted.
Oh, yeah, sure.
Thank you, Khai Xiang, for the sharing.
Thanks for having me.
So now we are at the end of the MLDA Insight.